everyone! In this video, we'll be showing you how to communicate between two ESP32s from around the world. This is what we have built. This is a demo of how it works in real life.
Peppy and I are in our apartments in Firebase in East Village, and we're each connected to a separate Wi-Fi network.
Cool. And this is the hardware setup that we each have. So we will go through the hardware setup as well as the code behind it in the next part of this video. So when I press my button, Yulia's LED will light up. And when Yulia presses her button, my LED will light up. And the real-time database will be updated constantly. So we're going to demonstrate right now. I'm pressing my button.
And the real-time database on the left-hand side updates and my LED turns on. And now if I press my button,
the real-time database is updated and my LED is lit up.
You can also use this method to do other projects such as this Lovebox Messenger, or you can basically use this technology to control any device from around the world. Here are some of the hardware components that we used in this video. 2 breadboards, 2 ESP32s, 2 sets of 4 male to female jumper wires, 2 push buttons, 2 LEDs, 2 220 ohm resistors, and 2 10k ohm resistors. And we also used 2 data transfer wires that can link your ESP32 to your laptop or computer. So instead of using Wi-Fi or Bluetooth to send data, we'll actually be using a real-time Firebase. This is because, first of all, Bluetooth doesn't allow super long distances, and second of all, the different ESP32s will be located in different locations, and hence they would be connected to different Wi-Fi networks. Hence, Wi-Fi wouldn't work either. So instead of sending data from one ESP32 to the other directly, the first ESP32 will be first uploading the data to the real-time database. The second ESP32 will then continuously check for updates on the real-time database and hence be able to read the data that is sent from the first ESP32. We will first set up Firebase, which is the real-time database software, and then we will program the ESP32s in Arduino IDE. Let's start building. Here's how our circuit looks. The link of this circuit diagram is also in the description below. Then connect your ESP32 to your computer or laptop. Now let's get started with setting up Firebase. In order to create a project, you must be logged in to your Google account. We shall first set up an account and a project. Head over to Firebase. Click Get Started and create a project. Give a name to your project. Disable Google Analytics. And now wait for it to load. Press continue, and now we're in the project console page. Now let's set our authentication method. On the left panel bar, select build and then authentication. Click get started. Select anonymous, toggle enable and then save. Let's now create the database. Head over to the left panel bar again, select build and then real-time database. Select Create Database, enter your location. In the security rules, select Start in Test Mode. You have now created your real-time database. Now the important part, copy and save the database URL into your notes. We will need it later in the ESP32 code. Now let's get our API key. Near the top left corner, click on the little gear and select Project Settings. This is another important thing to note. Copy and paste the web API key. We would also need this in our code.
And now let's close Firebase and open the Arduino IDE. Now go to Arduino, Settings, and then in the Additional Boards Manager URLs, paste the link that we have provided in the description to add the ESP32. Next, go to Tools, Board, Board Manager, and then search for the ESP32. Install the ESP32 by Express If Systems by clicking the Install button. If all of that worked, in Tools, Board, you should now see the new tab that's called ESP32 Arduino with all of these different ESP32 boards. Next up, we're going to install some libraries. For that, go to Sketch, Include Library, and Manage Libraries. And in the tab that opens, search for Firebase ESP clients. Now download the library for ESP8266 and ESP32 by Mobits by pressing the Install button. If it is properly installed, a green installed text appears. Next up, search for the Wi-Fi library. Scroll down to find the Wi-Fi inbuilt version by Arduino, and if you haven't already installed it, do so now. Now close the library manager and let's get coding. This code was heavily inspired by Rui Santo's example, so make sure to credit them. Next, we're going to import some libraries that we just installed and set up the Wi-Fi connections. Here, make sure to replace the Wi-Fi SSID with your proper Wi-Fi SSID, as well as the password with your Wi-Fi password. Next up, we're going to set up Firebase. Here, replace the API key with the API key that you copy-pasted from the Firebase website, as well as the database URL that you copied. And now we're going to be setting up the hardware components, the LED and the button. In this tutorial, we connected the LED pin to number 13 and the button pin to number 12. But if you use different pins, then make sure to replace them here. Here it is important to understand that the button state will be 0 if the button is not pressed and 1 if it is pressed. And now we're going to add some more code to define the Firebase data object and some other things such as a timer that we need to make this code work. Before we can move on to the setup function, we're going to import the connect to Wi-Fi function to keep our code tidy. Now in void setup, let's set the baud rate, set the LED pin as an output, call the connect to Wi-Fi function, and assign the API key and the database URL. The below code is needed to sign up to Firebase with our authentication methods and the API key. Let's get to the loop. In here, we're first adding an if statement that checks whether Firebase is ready to receive requests. And additionally, it regulates the amount of requests we make to the database. If we increase this number, less requests are made, and the ESPs are communicating slower. The first thing we're going to do is update the state of our button by reading the button pin. Like this, we can detect if the button is pressed or not. Next, we're sending the button state to the database for storage. We do this by calling the setInt function, because the data type of button state is an integer. The second parameter indicates the data path, so where the button state is stored in the database. We want it to be stored in Julia button state. Lastly, we indicate what data we're sending, and that is obviously the content of the button state variable. If this upload is successful, we will print button state was successfully saved to Julia button state in the serial port. And if it's not, we will print data upload failed. Secondly, we need to access the database to see whether Pepe's button was pressed. We do this by calling the getInt function, because the data type we're accessing is an integer. We also need to specify which data we want from the database. Therefore, we specify the data path again, which this time is Pepe's button state. Then we're setting the LED status to the data we receive from the database. This means that if we're accessing a 1 from the database because Pepe's button is pressed, the LED status will be set to 1. If we're accessing the integer 0 when Pepe's button isn't pressed, the LED status will be set to 0. In this line, we're turning on or off the LED based on the data we just downloaded and stored into LED status. Lastly, we check whether our request was successful via the serial monitor. Now go to Tools, Board, ESP32 Arduino and select your board. In my case, that's an ESP32 dev module. Now go back to Tools, Port and select the port you connected. Let's upload the code. Click on the little arrow, give your code a name and save it. The compiling and uploading may take some time, so be patient. Hit the serial monitor icon to open the serial monitor. Now you should see something being printed. If it's gibberish, adjust the baud rate to 115200 in the lower right corner. It is totally normal to receive some error messages, because we first need to set up the second ESP32. What is important for now is that Julia's button state appears on Firebase. To connect the second ESP32, copy-paste the same code into a new Arduino file, and just switch Peppy button state and Julia button state. Upload it to the second ESP32 the same way as before. Now everything is set up, and on Firebase, you should be able to see both Julia button state and Peppy button state. Click the buttons and see the values update on Firebase in real time.
And this is a final demo of what you should have achieved by this point.
Thanks to Random Nerd Tutorials, as we referenced a lot of our content from this video from their websites, and we hope you could follow this tutorial and everything worked. If not, feel free to leave a comment behind. Thank you!
Yay! Bye!